What's up everyone, my name's Roman and in this video we're going to be talking about the blockchain. Before we jump into it, if you haven't watched my previous video, I'll have a link to that down below in the description. It's sort of a primer about what Bitcoin is and it'll help you get a better idea of what we're trying to accomplish as we jump into the more technical aspects of the whole system. So, what is blockchain? If you watched other videos on it or maybe tried to Google what the blockchain is on your own, I'm sure you read the same thing over and over again. That is, it's just a series of blocks. That isn't where we're going to start. Instead, let's jump back to what Bitcoin is trying to achieve and build on from there. So, with Bitcoin, the work of a bank or a payment processor is replaced by a computer program. Now, usually these banks or third parties, their entire function is to just keep track of transactions and make sure that you're only spending money which you actually have. Now, the way traditional third parties do this is by having what's called a ledger, where they record every single transaction as it happens from you and from other people, and they make sure that you're only spending money which you have, and they take a fee for doing this. You also need to trust them to maintain this ledger and make sure that it's up to date and accurate. So, how do we accomplish this on the internet without relying on a single source of information that everyone must trust? Well, it's simple enough to have a piece of software that does this function for you. Most modern payment processors rely on software to do this function for them as it is. This software is relatively straightforward. It verifies transactions, makes sure that only valid ones are processed, and maintains a single copy of a digital ledger. So what was the technological breakthrough with Bitcoin? Simple. Removing trust from this entire process. Within the Bitcoin network, everyone runs software which maintains their own copy of this digital ledger. Within that digital ledger, you maintain a record of all transactions that have ever occurred. When you run the software, you share information about new transactions as they appear on the network with other users that you connect to. This means that at any point in time, you can verify a transaction independently against your own copy of this digital ledger. That takes care of the trust part. You're no longer relying on someone else to tell you whether a transaction is or is not valid. But this is where you start running into problems. Let's say I want to buy a car. I create a transaction sending all of the money that I have to the person selling me the car. I transmit this transaction to the rest of the network, asking other Bitcoin users to verify it for me and record it in their digital ledger. While this is happening, I create an identical transaction sending all of that money to my own account. I also transmit this transaction to the network. What this leads to is a race in the network between both of those transactions. Some people will see the transaction sending money to the seller of the car. Others will see the transaction sending the money to my other account. Eventually, all users in the network will see both transactions. What matters is the order that they came in at. If you've already recorded my money going to the seller of the car, you will reject my transaction sending my money somewhere else. Alternatively, if you've seen me move my money somewhere else, you will no longer accept that same money moving from the original account to the seller. It's just no longer there. This is what's called a double spend problem, and it exists because of the time it takes information to travel through the network. It only exists because everyone must maintain their own copy of a digital ledger. Up until recently, this has been a major hurdle and the reason why we've had to rely on trusted third parties to maintain a single ledger. Now, going back to our example, what this results in is a lack of consensus within the system. That is, if you're responsible for maintaining your own digital ledger, you're not going to trust the fact that others are telling you that actually the money went to the seller or actually the money went to this other account. What ends up happening is that as time passes and more transactions are sent, there is a higher and higher chance of there being a lack of consensus within the entire network. Money moves quickly, and the faster you can create transactions and transmit them, the higher the chance of consensus being broken. So how do you solve this? Well, this is where we loop back to blocks. If you think about your digital ledger, you process transactions as you receive them in chronological order. You could take your entire digital ledger and slice it into 10-minute groups of transactions, in this case, blocks. So how does this help us fix the problem of everyone's ledger being out of sync? Well, what if we all agreed that rather than updating our ledgers permanently every time we receive a new transaction, we only locked in a series of blocks? That means that you can still receive transactions and verify them, but you only consider them permanent and locked in once they're recorded inside of a block. These blocks of transactions allow everyone's digital ledger to have two parts. An active, uncertain part where you can keep an eye on new transactions, make sure there's no double spends, and verify any incoming transactions, and a locked part where all previous blocks which you and other participants in the network have agreed on are final. This is how you can maintain consensus within the entire network roughly every 10 minutes. Now I'm sure all of you are thinking what transaction goes into that block, the one sending money to the seller or the one sending it to your other account. Well, remember, we said everyone in the network understands that the active part of their ledger may not necessarily be final. All participants simply agree that any new block received forms a fixed portion of their digital ledger. If there is no one cheating the system, every time a new block is received, it should match the active part of your digital ledger. Otherwise, you simply substitute what you've been working on in your active part with this newly received block which everyone in the network has agreed on. Now remember, you may be the only one who's received a bad transaction. As you add block after block of new transactions to the permanent part of your digital ledger, you form a chain. This is where the term blockchain comes from. It's simply the descriptive technical term of your digital ledger and the way in which it functions. So let's summarize. Everyone maintains their own version of a digital ledger. This causes problems because of the nature of the internet. It takes time for information to flow through it, and this can result in transactions arriving in the wrong order. As time goes on, there is a higher chance of everyone's ledger being slightly different as a result of this problem. Bitcoin solves this by introducing the blockchain, a series of transactions roughly every 10 minutes which everyone agrees are valid and helps bring the entire network back to consensus roughly every 10 minutes. Now, the follow-up to this entire process is called mining. That is, whose version of the last 10 minutes of transactions do you accept as the new block? It's such an important part of the network that I will dedicate a separate video entirely to this process. In it, we'll discuss how a block is created and verified, all while maintaining zero trust in the Bitcoin network. Well, that's all from me. I hope this video helped give you a better understanding of the blockchain and how it ties the whole network together. If you have any questions or would like me to go into a deeper dive on any other aspect of the Bitcoin ecosystem, please let me know in the comment section down below. Make sure you hit that subscribe button to be notified when any new videos come out, and I'll see you in the next one.